By the way, this is one of the most important topics in kinematics because that's actually a big, big, big thing in first year physics. In fact, I think right now they are actually covering in first year physics at Western, whether science or engineering, they're actually covering kinematic equations right now. Okay, so it takes them about at least a week to go through the problem. Okay, so sometimes you might not have a graph that represents the kinematic situation being studied. Okay, I mean sometimes you do have a verbal explanation of it, or sometimes you have a graph. Well, sometimes you don't. Sometimes you have what we call a word problem, a pure word problem with nothing but just words and numbers, and you have got to make sense of every single part of it. Okay, sometimes you're not even allowed to use a graph, even if you can create one, maybe because there's no time. Or you know what? Not everything should be graph to be understood. You're grade 11 physics and you're applying to university or technical programs. You should be able to do a lot of stuff without a graph, just depending on your mathematical understanding of the situation. Okay? So what do? We have you to use algebra. No need to be under the mercy of graphs anymore. All right? All right. So kinematic equation. So in simplest terms, how many kinematic equations are there? Five. Okay, they are actually called the big five of kinematics. Okay, here's the thing, everyone. This is important. They can only be used in situation where what is considered uniform what? Uniform acceleration. So if your acceleration is not what? Is not uniform. So for example, what is a case of non-uniform acceleration? You're accelerating your acceleration, for example, or you do not keep the same press on the gas. You're pressing and you keep pressing and pressing and pressing, which means what? You're gaining your gain. Does that make sense? You're gaining your gain. That is not what? Uniform acceleration. Sometimes they are referred to as the big five because they're all you need to analyze uniform acceleration motion. So for example, am I ever going to give you a non-uniform acceleration problem and I ask you to analyze it using this? No. So the question now is, what if you have a non-uniform acceleration problem? How do you use it? How do you analyze it? Again, what's the last thing you take in math in high school? What's the last course you take in math in high school? Calculus. Calculus is needed for everything that you cannot do in what? In grade 11 or 12 physics or grade 11 or 12 math. Calculus basically is the answer to every single question of what if I can't do this? What's the next step? Calculus is always the next step. Okay? All right. Yes. Okay. Accelerate your acceleration. Then you can't apply that. Okay. So this is actually, I've been teaching physics 11 and 12 for 12 years. This is my first time actually taking the job of creating the kinematic equations one by one. I've always given them to you. No, let's actually create them because that will actually make you understand why they look the way they do and actually give you some mathematical exercise. So the first one you don't need to create. First one just happens to be what? Did we cover this equation before? Yeah, this is just purely the definition of what? Average acceleration. So interesting. One of the equation is already what? Is already done for us. One of the equation this is actually called equation number one. AAV equals VF minus VI over delta T. Done. We're done one of the five. 20% done. Okay. Let's do the second one. Okay. Everyone, the second one is going to be created by what? By looking at what kind of a graph is this? It's a velocity and time. Okay. So the second one of the five equations is going to be obtained by looking at the area under velocity time graph for an object moving again with what? With, come on, moving with constant or uniform acceleration. Okay. Everyone, go ahead and shade this region right here. So go ahead and just shade this region. This is what we're trying to what? This is the area we're trying to find. The area, so this is the area we're trying to find. Okay. Question. What is this area? What is this shape? What kind of a geometric shape is the one shaded? It's not a triangle. It's a what? It's a trapezoid. Why is it a trapezoid? Because it has what? It has how many sides, first of all? Every trapezoid only has four sides, such that those two sides are what? Parallel, and those two sides are anything else. Okay, anything else. They are not parallel, and they're neither parallel, nor they're what? Equal length. This one is shorter than this one. Okay. So the question is now, does anyone know what is the equation? What is the equation of what? Of the area of a trapezoid? How many people remember it? Yeah, and that's why, remember, what do we always break a trapezoid into? A triangle on top of what? On top of a rectangle or a square, depending. Well, I'm going to show you today the equation for what? For a trapezoid area. So everyone, go ahead and write this down. Area, A, capital A, trap equals. Okay. Okay. It's a fraction. Is there a triangle involved? Yes. Which means, okay, who remembers the area of a triangle? Base times height divided by. So the equation for the area of a trapezoid also has a division by what? Perfect. So let's just put a 2 here. Okay. Now comes time to the what? Now comes time to the top part. The top part is, everyone, the top part is the small base. So one of the bases plus the what? The other base, so the two parallel sides only, times what? The height or the basic what? The thickness of the shape. So first of all, what is so base 1 plus base 2 in brackets times the what? Times the height of the shape. And the height of the shape is basically how far are the two what? How far are the two bases separated? Okay. So first of all, so I want you to write how could oh, so this is the equation, everyone. A plus B, go ahead. A plus B times what? Times if you break it down like that, that's exactly what's going to boil down to. You're absolutely right. Okay? But this is actually the equation in one shot. So I'm going to show you today the equation in one shot. So what is A and B? They are the what? Base 1, small or large, base 1, base 2. And what's H? How far apart they are. Okay, let's apply this to that. So A equal. Okay. How big, how long is this line? Remember, again, we have a dimension of T and we have a dimension of V. How long is this distance? It's what? It's your VI. So, okay, hold on. VI plus. So your initial velocity or speed. Let's say it's speed because you're going in one direction. What is B? All of this. All of this, which is what? Your final velocity. All of it, including what? Yeah, from 0 to here and then from 0 to here. Okay, what's H? Exactly. H is how far this distance is. What do you call TF minus TI? Whenever you subtract final minus initial, what do you call that? Delta what? Delta time, exactly. So this is equal. So A of the trapezoid equals VI plus what? VF, VI plus VF times what? What did you say the height was? Delta T, all divided by. Are we good so far? By the way, we're not doing physics. So far, we're just doing what? Math, geometry. Here's a question for you that relates to physics we did last week. What is the area under a velocity time graph? What do you get when you do the area under a velocity time graph? When you added these areas last week, what did we get at the end of the day? Distance. Thank you. Ladies and gentlemen, here's the second equation. The second equation is delta D equals, and I'm going to write it the way it's officially written. You pull the half out. You pull the half out. So you write it first like this. Again, don't ask me. This is just the way they write it. Half. What's in the bracket still? VI plus VF. And what multiplies that? Ladies and gentlemen, that's your second equation. Oh, okay. How did I get the 1 over 2? Technically, there's a 1 here, right? So all I did was what? Pull out the 1/2 and just separate these. Okay, Juman, think about it this way. Technically, what's under this? What's under this? 1. So it's 1 times 2. Same thing, 2. And then there's delta t times the bracket times 1. Delta t times the bracket times 1. Make sense? You just split it up. And I'm only showing it to you this way because that's officially the way they show it in what? In grade 11, grade 12, and first year physics text. In fact, everyone, flip the page. Hold on one second. Sorry. Here. Do you see this table? These are the 5 kinematic equations. Do you see how it's written? It's written exactly the same way I just showed you at the end. Do you see what I mean? That's why I want to show it to you the way it's going to look like for the rest of the course. But you're absolutely right. Can you still think of it this way as the whole thing dividing 2? 100%. And sometimes I might manipulate it to actually look at it this way. So, ladies and gentlemen, this is equation number what? Number 2. Okay, let's go to equation number 3. Okay, equation number 3 is obtained by what? Come on. Combining equations what? 1 and 2, the one we just did, but eliminating which one? Final velocity. So what does this mean? Okay, can someone tell me what's equation number 1? Come on, what's equation number 1? Okay, what's equation number 2? We just delta D equals what? Half the addition of the 2 times delta T. What does it mean to combine and eliminate? It means look at one of the equations and rearrange it to solve for what? So solve for final velocity, and then what do? You plug it into the what? Into the second equation. Does that seem like something you did in grade 10 math? How many people remember the method of substitution and elimination? What we're going to do right now is what? Is substitution. What are we going to substitute? We're going to substitute equation 1 into equation what? 2. But using which variable? In this case, final velocity. Okay, so everyone, let's look at equation number 1. So, number 1. What's the equation? The original equation. A, and you know what? Let's skip AV. A is AV, okay? So A equals VF minus VI over. And also, what do I seem to be skipping as well? The what? Okay, yep, let's make it scalar. By the way, you're going to see that from now on, we're going to deal with more scalars than what? Than vectors. Okay, how could I rearrange this, everyone? How could I rearrange this to, what do you call it? To solve for VF? I could what? Cross multiply, which means it's going to be what? VF minus VI equals what? Come on. A delta T. Okay, I'm almost there. Technically, I have not isolated VF yet. What do I do now? I move the what? I move the VI to the other side. So what do you get? VF equals A delta T plus what? Or VI plus A delta T. By the way, do you know why I like to say VI plus A times delta T more than A delta T plus VI? I don't know. To me, for 25 years of like helping people with math and physics, this kind of like gave me a better way to see it. Because what's your final velocity? It's your initial velocity, and then what? Plus the what? The addition acceleration you got through. Do you see what I mean? Final velocity is VI plus what? An extra what? An extra what? An extra push. Do you see what I mean? That's why I like to always write it this way. What am I gonna do now? This is VF. Where am I gonna feed it to? I'm gonna write the second equation now. So let's write the second equation. Delta number 2. What was the second equation? Delta D equals 1/2. Yep, either way. VI plus VF. Okay. What does it become? This VF has to be what? In favor of what? All of that. So what happens? This, yes, whatever VF becomes the new expression. That's the method of substitution. You substitute. So delta D equals 1/2. Okay. Does this VI change? No, I'm not changing the VI. I'm changing the what? The VF. So VF, sorry, I mean VI. My bad. Second. VI. VI plus what? Plus plus VI plus. Do you see what I just did? All I did was take this block right here and replace it with this. Do you see what I mean? That's yes. By the way, half of the equations in math and physics are derived this way. You have a couple of equations and then you what? You combine them together. Yes. Where did the VF go? It's still there, but it's what? It's written in a what? In using different variables. Do you see what I mean? It's still there, but it's written in terms of what? VI, A. Do you see what I mean? It's exactly. It's written in terms of other variables, but is it still there? It is still there. It's just what disguised in terms of what. It's like saying, how many people did factoring? When you factor, what do you put in the brackets? Do you put the x squared or just a single x? And what's the big question that everyone says? Where did the x squared go? It's still there. How do you prove that's still there? When you what? What's the opposite of factoring? It's still there. It's just been what? Been split up. Do you see what I mean? Everything is there. What's vi plus vi? Oh, don't you dare say vi. Everyone, what's the biggest mistake when you ask people, what's x plus x? Now, x plus x is just what? 2x. What's the wrong way of saying it? X what? You never, when you add or subtract, do you get a higher power or just a bigger amount? But when you multiply or divide, what happens to the powers? If you multiply, they go up. If you divide, there you go. When you multiply, you change the powers. When you add or subtract, you change the what? The amounts or the coefficients. So times what? Sorry, bracket. And then times what? All right. Let's clean up. What's up? Go ahead. Uh-huh. I do have two delta t's. That's the whole point, actually. What's vi plus vi? Come on. All right. 1/2, 2 vi's, still plus what? A delta t. That's untouched because it's not the same thing. Delta t. Perfect. Okay, keep going. What's the only thing we can do now? Expand, right? Okay. Should we multiply the half first, or should we keep it and then do these first? Okay, everyone. My personal advice is that whenever you have a number multiplying a bunch of brackets, keep the number until the what? Until the end. Deal with the brackets first. Why? Because then your numbers stay nice and clean until the what? Until the end. Do you see what I mean? Do not screw up your numbers at the beginning. Leave screwing the numbers until the end. Do you see what I mean? Okay, so what's 2vi times delta t? 2vi delta t. Like, what's 2 times x times y? 2xy, right? So this will be what? Half 2vi delta t plus, okay, what's a times delta t times delta t? A delta t squared. And now what do I do as my very last step? I put the what in? I put the half in. So what's half times 2? What's half of 2? 1. Half times 2, the 2 cancels the 2. Like the 2 from the bottom cancels the 2 from the top. So you just get vi delta t, right? Plus what? Sorry. Plus half a delta t squared. Ladies and gentlemen, say hello to the third kinematic equation. Let's see if they do have the same what? The same measurements. Everyone, what's the unit of vi? Come on. What's the unit of vi? Meter, no, vi, just vi. Meters per second. What's the unit of time? No, no. Seconds. What's meters per second? Times seconds. What happens to the seconds? They cancel. And what do you only survive with? Meters. Interesting. Distance. Hold on. Keep going. What's the unit of acceleration? Meters per second squared. What's the unit of time squared? Seconds squared. What's meters per second squared times second squared? Again, just meters. Perfect. Which makes sense. Because what are we supposed to survive with at the very end? Distance. Do you see how we are building it to actually agree with what we're trying to find at the end? We want the end to only be what? Distance, which is what? Meters. Did this one boil down to be meters? Did this one boil down to be meters? Yes. Did this one also boil down to be meters? The equation checks out. That is the third equation. Everyone, go to the second page, flip to the table. Is that indeed the third equation? Exactly. And you thought you were only going to learn physics in this course. Okay. Equation number 4. Everyone, do you think equation number 4 is going to be almost the exact same derivation? Okay. Baha, you and me, we'll do this one. Okay. By the way, I have a typo. And it should say, in the equation number 4, it should say what? You have it saying what? Yeah, so please change it. So go to equation number 4. And by the way, I'm not going to go to another slide. I'm just going to change whatever I need from here. So go ahead. Just change this one in equation number 4. Just change it to fourth. The fourth. No, yeah, no, I'm saying it's got to look like equation number 4. It should be fourth here. Okay. But now we're going to eliminate what? VI. All right. So VI. You're right. Let's prove it. Come on, everyone. Are we still going to start with this? Am I going to still go to this step? But now, what am I going to do? Exactly. Instead of solving for VF, I'm going to solve for what? VI. So how is this going to change? VI is equal to VF minus, which makes sense. Because what's VI? It's VF, take away what you added to it. You see? VF is VI plus the push. VI is VF minus the what? Minus the push. All right, so let's do it. So VI equals what? VF with a what? Minus. So VI equals VF minus A delta T. Okay. Am I still going to start with this one? Let's say I want to build it from scratch. Which one of those now is going to change? Come on. VI. So that means VF will stay the same. VI will become what? VF minus A delta T. So what is this going to become? This is going to become this. I'm going to erase. Okay, let's do this. VI disappears. It becomes what? VF minus A delta T plus what? How many people agree this is correct? Remember, I'm substituting. I'm replacing. Uday, do you agree or do you have a question? Go ahead. Did you say factoring? No. Did you use the word factoring? By the way, did we factor anything here? We're not factoring. We're what? We're substituting, and then we're not even factoring. We're expanding at the end, right? Because I'm spreading out the whole thing. When do you know that you factored? When you create what? We're not creating brackets. If anything, we're what? We're destroying the brackets, right? We're opening them up. If you're saying this is cleaning up, this is as basic as it gets when you what? Think about deriving an equation from another what equation. It's literally no physics. It's just what? This is just math following from math. What do we do here? Come on. I have a VF plus VF. What does that become? 2VF. So 2VF. But it's a what? It's a minus. Okay, what is this going to become? Almost the same thing. But instead of what? VI, it's going to be what? And instead of plus, it's going to be? Go ahead. Yes. Everyone, listen up. Jaman, just one. Yasmin is saying, are you just showing how the equations got created? Yes. Am I ever going to ask you to rederive those again? I do it once because I always want you to know. But to your point, I will never ask you to rederive anything. I will show you how to what? How to use the toolbox. 2VF. But yeah, see. Yeah, no, 2VF. I'm just cleaning up. 2VF minus VF minus. So what's the final equation? Come on. VF delta T. Fifth equation. Why would I do 4? By the way, do you want me to assign this as homework? Thank you. Because trust me, sadly, you've not been taught with the tools to really navigate your way through this. So I'm going to do it for you. All right. What am I saying here? Still, we're going to combine equations. What? Yeah, by the way, we always combine 1 and 2. But this time, we're eliminating what? Time. Let's eliminate time. So let's look at equation number 1. Yes. How are we going to eliminate this one? How do I play with this to isolate delta t? What's my first step anyway? Cross multiplication. All right. Cross multiply. What's going to be a delta t? Okay. How do I clean up to get the delta t? Okay. Remove the a. How do you remove the a? Divide both sides by a. So that means what? Delta t equals Vf minus Vi divided by what? Now we go to what equation? Which one? We already are done with equation 1. Now I go to equation what? Equation 2. Can someone remind me what was equation number 2? Delta t equals? Uh-huh. Whoa, whoa, whoa. Let this sink in. You will see something that you're not going to believe happened. What am I going to write instead of delta t? Hold on, hold on, hold on. Do you see how the second equation has delta t in it? Do you see how I solved for delta t at the top? Can I substitute? What am I going to do now? I'm going to take this block, put it right here. Do you see what I did there? I invented a small expression for delta t, and now I'm going to what? Substitute it or plant it in another equation. Okay, so what is this going to look like? Half Vi plus Vf times what? Times what? Come on. No, you're right. When you substitute, you literally replace and put. Done. Okay. What do I do? What should I do now? First of all, what do I have here? What do I have here? Okay, let me do something here. I am going to. No, I'm not doing anything. Look what I'm gonna do. Do you agree this is still okay? Yeah, because a plus b is the same as what? Who's taking functions now? What's a plus b times a minus b? What's a plus b in a bracket times a minus b? Here's the good news. Even if you don't get it, you're still going to be able to apply the kinematic equations and get 100% on the unit test without fully understanding why this works. What's a plus b times a minus b? How many people heard of factoring? How many people heard of difference of squares factoring? A squared minus b squared. What's a squared minus b squared? How do you factor? Yeah, what's the square? What's the factoring of? Hello. This is just the what? This is just the factored form of a squared minus b squared. I am going to show you that math and physics are really two sides of the same coin every single day you're in my class. This is a plus b times a minus b, right? Everyone, do you agree this is correct? Look, do you agree this is correct? A squared minus b squared is the same as a plus b times a minus b. Do you agree? If you don't know this, you have trouble in 3U math. So isn't this the same as that? Great. So when I multiply these two, what am I going to get? Vf minus, you got it. Oh, no, it's still there. I'm just cleaning up level by level. But do you see the relation now between factoring and that? No. I'm not factoring it. It's already factored. I'm expanding it. I'm cleaning it up. This times that. By the way, what's under this? No, what's under this? 1. So we know it's 1. So what is it going to be? Just give me 1 second. So what is this going to be? 1 times Vf squared, subtract what? Squared over what? 2 times 1 times. Where they get what? Yes, yes, please, go, go. Don't let anything stop you. Where they get what? Okay, good. All right. Now, hold on. I want you to look at the table. Tell me if this looks like the final equation. No, it doesn't. What do you think I should do now? Now we crisscross. All right. Did you see that meme where you know what? You look down and then you look up and then the board is full? That's exactly me. It's exactly me. All right. Hold on. Let's finish this. What's these two? Come on. Which is what? Vf squared minus. And what's these two? Okay, so what's the equation after? Say again, what? Oh, no. 2 times technically 1 times A. All the bottoms multiply together. All the tops multiply together. Good, good. Vf squared minus equals 2A delta D. Hold on. One second. Yasmin, you. Tell me how the final equation looks like. Read the final equation for me from the table. Shh, everyone. Yasmin. Vf squared, which is going to be when you move this guy to this side. Done. We just derived the equation. Can we rewrite equation number 2? One more slide. No. We're not going to do the math. I want to explain to you why we need how many equations? 5. Everyone. So do you agree those are the 5 equations? All right. Question for you. What is missing from the first equation? What's missing from the first equation that is in here? Come on, tell me the symbol, not the name, the symbol. Delta D. What's missing from the second? That's present everywhere else. What's missing from the second one? No, from the second one. What's missing from? Come on, guys. No, guys, phones away. Let's just discuss this. What's missing from the second? Equation 2. What's missing from it that is present everywhere else? A. So this one is missing what? This one is missing what? D. What's missing from here? VF. What's missing from here? What's missing from here? Every equation has how many things in it? 4 variables and missing what? That's why we have how many equations in total? 5. So, everyone, let's what? Let's go to this slide. Come on. Okay. What's missing? Everyone, what's present here? Come on. What's present here? What's missing? Go ahead. Put an X at the delta T. Sorry, delta D, my bad. And what do you put here? Check. What's missing from that one? Check. What's missing from here? Yes, you're right. Check. What's missing from here? BI. Time, where is it? Right. That is going to be how you use the what? How you use the kinematic equation. Depending on this, you know which equations you can't use and which only one equation you need to. Question for you: Can I use the second equation to solve for acceleration? Why not? Because it doesn't even have it. Can you use the third equation to solve for VF? VF, third equation. Because it doesn't even have it. So you can plug it in and you can solve for it. Do you see what I mean? That's what. This is the toolbox.